Welcome back, SQL enthusiasts. Ready to tackle those pesky duplicate records? Have you ever run a query and noticed the same data appearing more than once? This can lead to incorrect reports, miscalculations in data analysis, and overall database inefficiencies. But don't worry, in this video I'll show you exactly how to identify duplicate records and, most importantly, how to remove them safely without losing valuable data. Before we jump into SQL queries, let's first understand what duplicate records are and why they matter. A duplicate record occurs when multiple rows in a table have the same values in one or more columns. This often happens due to data entry errors, faulty data migration, and incorrect joins between tables. At first, duplicates might not seem like a big deal, but they can cause serious issues, such as inaccurate financial reports due to duplicate sales data, confusion in customer databases leading to poor communication and service, and slower queries and wasted storage in large-scale applications. Let's take a look at this simple students table. Here we see Sarah Wilson appearing twice with the same subject and marks. This is a duplicate record, and we need to find a way to identify and remove it safely. So, how do we do that? Let's switch to SQL Server and start writing some queries. Let's jump into SQL Server and explore how to find and remove duplicate records effortlessly. We already have a table named Students containing student details such as student ID, name, subject, marks, and gender. Let's retrieve all records to examine the data. For this, let's write the query. Select star from Students table. This query fetches all records from the Students table. Here we can see that ID number 6 belongs to Sarah Wilson, who has maths as her subject and scored 78 marks. The same data appears for ID 16, making it a duplicate of ID 6. Now let's explore different ways to find and remove these duplicate records. Let's check the first one. The first method to find duplicate records is by using the count function with group by and having. Let's write the query. Select name, subject, marks, gender, count star, as duplicate count. From Students table, group by name, subject, marks, gender, having count star, greater than 1. Let us run this query. Now our duplicate record is listed, Sarah Wilson. Let us discuss what we have done with the query. We group records based on name, subject, marks, and gender, meaning that students with the same values in these columns will be treated as a single group. Then, we use count star to count how many times each group appears. The having count star greater than 1 condition ensures that only groups with more than one occurrence, duplicates, are included in the result. This method is simple and effective for small datasets. However, on large tables, count can be slow because SQL must scan the entire table, group the records, and count each group before filtering. Adding an index on the grouped columns may improve performance slightly, but for extremely large datasets, more optimized approaches should be considered. Now let's explore a different approach using a common table expression with the row number function. This method is super handy when you want to pinpoint duplicate records clearly and efficiently. Alright, let's write the query then. With duplicate records as, select student ID name, subject marks gender, row number over, partition by, name subject, marks gender, order by student ID, as row num, from Students table. Select star from duplicate records, where row num greater than 1. Let us run the query. Here also we got the duplicate record as Sarah Wilson. Let us now analyze the query. First, we define a CTE named duplicate records, which acts like a temporary result set. Inside this CTE, we use the row number function. This function assigns a unique row number within each group of duplicates based on name, subject, marks, and gender columns. Essentially, it's like giving each duplicate record a unique ID. Records with a row number greater than 1 are considered duplicates, while the first occurrence is unique. Now let's talk about performance. Compared to the count method, this approach is generally more efficient for large datasets because it avoids multiple scans and counts. However, keep in mind that row number requires sorting and partitioning, which can be slow if your dataset lacks proper indexing on the partitioning columns. Next, we'll explore a third approach using a subquery instead of having. This can be particularly useful when having isn't the best choice for performance. Let us see the query. Select name, subject, marks, gender. From. Select name, subject, marks. Gender, count star as num. From students table. Group by name, subject, marks, gender. As statistic. Where num greater than 1. Now we can run the query. See, Sarah Wilson has the duplicate entry. Here's what's going on with this query. The inner query groups the records and counts the occurrences, similar to the group by method. Instead of using having count star greater than 1, we assign the count to a column named num and filter the records in the outer query with where num greater than 1. Performance-wise, this method can sometimes be faster than using having, especially when you need to filter duplicates before joining or applying other transformations. However, it still requires a full table scan and aggregation, making it less efficient for very large datasets compared to the row number method. That's it for the different methods to identify duplicates. Now let's summarize what we discussed. Count with group by and having is easy to understand but can be slow for large datasets. Row number with CTE is more flexible and efficient but requires sorting. The subquery approach can be an alternative to having but still involves grouping and counting. For small to medium datasets, count with group by works well, but for large datasets, row number with CTE is often the best choice. Now that we've identified duplicates, in the next section we'll explore how to remove them efficiently. Stay tuned.